So we have some additional fire safety features we want to talk about for the new mass timber construction. And I want to emphasize one of the principles here, and that is, this is a new principle. It only applies to mass timber in the code. We're all used to tested assemblies that achieve fire resistance. We're used to calculating fire resistance of exposed mass timber or exposed heavy timber elements. But this principle, this is the code text, and Jason explained this. I just want to reemphasize. The fire resistance rating of mass timber elements consists of the fire resistance of the unprotected element added to the protection time of the non-combustible protection. So for instance, if the floor is a 2-hour floor, right here, there may be some inherent fire resistance or designed fire resistance in the exposed floor. You can add that to what's provided with the gypsum to get the total fire resistance. There's 2 ways to do this, by the way. So the question is, how do we determine the amount of fire resistance provided by the non-combustible protection? One way to do that is by testing. You set up a test program where you're testing the unprotected element, like the unprotected CLT floor, and you test it to failure by ASTM E119 or UL 263. Take the same element, protect it with non-combustibles, test it again. The difference in fire resistance rating time to failure, that's the amount of contribution the non-combustible protection is providing. The general principle, as we said, is it must provide at least 2/3 of the overall required rating of the element. There's also a prescriptive option for achieving this. So in Chapter 7, you'll see 2 new tables. Fire resistance rating of the element over here, required contribution from the non-combustible protection in minutes over here. You want to know how many minutes you get with these types of gypsum wallboard? Here they are. Right. Remember, this also applies to type 4C because there are certain elements in type 4C that do need to be protected, such as exit shafts. Attaching the gypsum, the code will contain requirements for specific attachment of the gypsum. They do have to be staggered layers, offset layers, a stair-step profile at wall to ceiling and wall to wall intersections. Primarily important wall to ceiling where the gypsum ceiling is resting on the wall ceiling at each layer. All right. Super tall buildings currently in the IBC, when they get to 420 feet, their sprinkler systems have to have a redundant, in other words, 2 separate water supplies. This requirement was chosen to kick in at 120 feet for tall mass timber buildings. Another requirement, 703.9, you'll find sealing of adjacent mass timber elements. So a mastic or a caulk or an adhesive in between mass timber elements where they join. This is not for any quantifiable fire resistance. This is to prevent air movement, to prevent smoke movement throughout the building in the case of a fire. And then finally, this non-combustible protection on mass timber elements is very important. So what if someone who's using the building decides to remove it? The committee said, let's put a provision in the fire code that requires owners to document their maintenance of the non-combustible protection on the mass timber so that they have a record of it if something is damaged or removed and a fire official makes an inspection of the building. They're going to be able to receive from the owner, and it is a responsibility of the owner to maintain the fire resistance. They're going to be able to ask for that documentation, inspect any areas that perhaps were damaged or not protected. How about during construction? Construction fires are a very serious matter. We do have a construction fire safety coalition. You can find that information on our website. For mass timber buildings, it will also be important. all the typical requirements for fire safety during construction in Chapter 33 of the IBC and the IFC will apply. Standpipes when the building reaches 40 feet, water supply for fire department operations, access to the site, even fire watches at the order of the fire official. It's not listed here. These will all kick in as is currently required. But in addition, as mass timber buildings go up, we're going to require, the provisions are going to require that the protection begin as the building go up. So the idea here is we don't want a lot of exposed mass timber at a very vulnerable stage of construction. As we get taller, as we get up beyond 4 stories above what's protected, before we go higher, we're going to have to protect the story that's more than, the first story that's more than 4 stories below the floor of active construction. So if this is the 9th story, before construction begins at that, you have to protect this story here, which would be the 4th story, and then you can move up. This is simply 1 layer of gypsum that's required as an initial deterrent against ignition, even if there's more gypsum required to be installed later. You have prescriptive fastening for the exterior, the required exterior non-combustible protection of 40 minutes. Just so you know that's in there. I'd like to talk now about 3 particular changes that Jason mentioned. They're happening in this code change cycle, Group B. The first one has to do with connection protection. The heading of this section, new section as it stands right now, says connection fire resistance rating. However, as we all know, there's no standard in the code currently for the testing of connections and their fire resistance. What this is talking about, if you're familiar with current heavy timber design and when heavy timber construction is required to be fire resistance rated, it's not always required to be fire resistance rated, but when it is, the connectors between rated elements have to be protected with materials that equal the same fire resistance as the connected elements. That same principle will be carried through with this provision that's been approved by the committee, Code Development Committee, and will be up for a vote and is anticipated will get approval because it has good consensus in the fall. The trigger here, or the goal or the focus, is the temperature rise on the connector itself, but the principle is the same. You will be protecting the connections or the connectors with materials that equal the fire resistance rating of the connected elements of what their required rating is. You have a good resource now. Technical report number 10 has been revised to include all provisions for CLT, including the protection of connections and connectors. So there'll be some design, there are some design examples in here, and you can download this off our website. Among the Group B proposals are the requirement to inspect that cover for connections back in Chapter 1. And there will be special inspections required for mass timber construction. They will be listed in a table if this is approved, we're assuming it will be, in Chapter 17. You can take a look at that. In the current monograph, you can find the committee reasons for that. I'm going to go back to a poll question now. Marcy?
Yep. So we're going to fly through these real quick, but in types 4A and 4B, what minimum contribution must be made by non-combustible protection? Is that half of the required fire resistance rating of the building element, 2/3 of the required fire resistance rating of the building element, 3/4 of the required fire resistance rating of the building element, or none of the above? All right, I've got 30 seconds. I'm going to go ahead and close. All right, 61% say 2/3 of the required fire resistance rating of the building element. What do you say, Paul?
They're correct.
Excellent.
So The principle is required rating of the element, 2/3 of it has to be provided, at least 2/3 have to be provided by the fire resistance, or by the covering, non-combustible covering. All right, finally, let's talk about building sizes. There are restrictions, of course. They are increased over conventional frame construction. They're not as much as type 1A, for instance, but this is height in feet. Just a little excerpt of the table, just showing you an example. Say group B, type 4A, 270 feet, type 4B, 180 feet, which is parallel to the type 1AB. The committee chose not to make the height unlimited for type 4A. And for C is the same height as is currently required for heavy timber, regular heavy timber. And by the way, I'll go back up to that for a moment. These rows over here are non-sprinklered and sprinklered, but at high-rise heights, they're always required to going to be sprinklered, and even at low-rise, group R is required to be sprinklered. About height in stories, here's the top one, B18. It's the same as for group R. That's for type 4A, 12 stories, 9 stories. This is just showing group B in the top of the table here. You can see that it's reduced for certain occupancies. The committee used some judgment about this based on relative risk and function of the building. And for group R, that 9 turns into an 8 for group R. Allowable areas are increased, but they're not unlimited areas, and as in accordance with type 1. They're comparable to type 4 HT with a factor. Factor is considerable when you get over here with the high protection of type 4A. But I'll remind you that taking this row here, sprinklered multi-story, it's the most applicable row. The area of the entire building cannot exceed 3 times the allowable floor area for a single story in a multi-story building. So you get to multiply that by 3, and then you have to spread that total building area out among all the stories you have above. So as you go higher, your floor areas will get smaller. Here's a summary slide about 4A. I think these are helpful. Most use group, or many use groups, maximum height 270. Not all, certainly not H, not E, and some of the others. Not I, certainly. 9 to 18 stories, fully exposed mass timber, fully protected. Sprinklers, yes. Primary structural frame, 3 hours, 2-hour floors. Here we go. Fire resistance rating from the non-combustible protection, 120 minutes on the primary frame. Stair towers must be non-combustible. Jason mentioned that, and then can have concealed spaces, but they have to be protected. Let's take a look at type 4B. 180 tops out, depending on the occupancy, 6 to 12 stories. You can definitely have some exposed mass timber, which is a nice feature. Sprinklers, yes, 2 hours, 2 hours, 80 minutes. Protected mass timber is permitted for the stair towers. Again, this is only up to 12 stories, 180 feet. Beyond that, you have non-combustible stair towers. And concealed spaces, okay, if protected and so forth. Type 4C, this corresponds to the current height limit for a sprinklered heavy timber building as it stands in the code right now. Stories could be increased over what's permitted in the code though right now. Mass timber can be fully exposed, but of course, not in the concealed spaces, not for the stair towers, not for other shafts through the building. Those do have to be protected. Still have the high type 4B ratings, 2 hours, and so forth. Nice schematic that compares these. The total building areas here are listed below here. Again, this total building area would have to be spread out between all these floors. This is not a single story area, it's a building area. And you have to divide that by 18 to get the allowable floor area in that case. This is current heavy timber here. So you have those total building areas that might be helpful. And if you want to go back and actually read the text of the code changes, type A, group A cycle, here they're listed and their numbers. You can find it on the ICC website in the monographs. And I think we have another poll question. Let's see.
One more, and this is the last one. So for certain occupancies, which is true regarding maximum height and number of stories for proposed types of construction? So is that type 4A can be 270 feet and 18 stories, type 4B can be 180 feet and 12 stories, type 4C can be 85 feet and 9 stories, or all of the above. 87% say all of the above. And are they right?
They're right.
Excellent.
Well done. I think we're going to turn it over to Buddy Showalter. Buddy?
Okay, Paul and Jason, thank you both very much. There's a question about the ATF tests and just the fact that those were fairly open, ventilated test structures. Was that on purpose? Is that representative? Talk a little bit about kind of that whole test setup.
Sure, yeah, I'd be happy to. Yeah, the TWB committee made the decision to have that size opening because it basically represents a case where you have a curtain wall on one whole side of the building. In fact, I guess in a lot of cases, you might actually have curtain walls on more than just that one side. But for the purposes of data collection and also making sure that all of the entire plume went up into the hood in the test lab, it was necessary to keep all of the openings on just one wall. Typically, there would be a glazed curtain wall on a building like that. In fact, in tests 4 and 5, there was a glazed curtain wall installed on those openings, and you could see the effects, basically, that stifled growth of the fire because of lack of oxygen. And so the TWB committee wanted to ensure that the fire had a chance to get going and that it would reach flashover. And so they opted not to put glazing on that wall, on wall A, over those openings, in order to ensure that the fire actually did get going. Just one point I wanted to make: in test 5, the entry door near the kitchen had to be left open in order to allow enough air to get into there to actually allow the growth of that fire. Remember, if test 5 was the test where there were sprinklers, but they were deactivated on purpose in order to allow the fire to give it a chance to grow and reach flashover in the kitchen and become a fully developed fire, and then manually charge the sprinklers to see how well they can bring the fire under control. Of course, test 5 also had the glazing, as I just mentioned. So in order to allow enough air to get in there, that entry door had to be left open. And in addition to that, a decision was made during that test to go ahead and break some of the glazing in order to allow even more air in there to allow it to get started, because it was, even with that door, the kitchen door open, it was still struggling to grow because of the lack of ventilation. So anyway, that the ventilation there was, or the fact that they opted not to put glazing over those openings was simply to allow the fire to grow.
Great. Thanks for that.
TWB opted to do that.
Okay. Thanks for that background, Jason. That's really helpful.
Sure.
Paul, there was a question about firewalls. Can firewalls be used in these new types of construction to increase building areas like we do currently in other types of construction?
Yes, if it's a true firewall, which has a lot of, for buildings of this height, that's going to be difficult to accomplish. But yeah, as for any other type of construction, you can use firewalls to create a new building.
Great.
Build on the other side of the firewall. Yep.
Okay, super. Jason, question about connections, both in the ATF tests and then for design of connections. Talk a little bit about provisions for that.
Sure, and just to clarify, I'm going to answer that question from the perspective of the fire performance of connections as opposed to structural design of the connections, because I think that's what you're asking.
Correct.
So, yeah, the fire performance of connections, as Paul mentioned, and he actually showed the provision that's working its way through the Group B code development process and into the 2021 IBC that states the requirement for fire protection of connections, and that requirement states that connections have to have protection covering them that is sufficient to provide at least the same amount of fire resistance rating as that which is required of the members that are connected by that connection. And I want to stress the point that I made about that's the protection over the connection. That doesn't mean that you can have a fire resistance rated connection per se, although there may be some proprietary designs for a quote unquote fire resistance rated connection. Really, it's the protection over the connection that gives it its fire resistance rating, and that can be achieved by adding either some kind of non-combustible protection over it, like gypsum wallboard, or it can be achieved by additional wood cover, provided that you're under a construction type that allows you to have exposed mass timber, such as types 4B or 4C, and that's how you can achieve it with the additional wood cover. But it's the protection over the connection that needs to be used to provide that fire resistance rating. And then I also wanted to point out, your question was kind of a two-part question about the connections in the ATF test structure. There were several different types of connections, including beam to column connections and different types of those, also different types of beam to column connections between the glulam beams and the glulam columns. And also there were different types of connections between the CLT floor ceiling assembly and the CLT wall within the ATF structure. And they were all protected as would have been required for the type of construction that each respective test represented.
Great, thanks. Paul, back to you with concealed spaces. We talked about the concealed space requirements for these new types of construction, but I think there's some new provisions separate from the tall mass timber changes for heavy timber, traditional heavy timber in concealed spaces. Can you talk a little bit about that?
Sure. Yeah, unrelated to the Tallwood Building Ad Hoc Committee changes, there was a change in this past cycle, Group A, that would allow the same type of protection for concealed spaces in traditional Type 4 heavy timber as is required for these spaces in mass timber now. And this protection is also mirroring the protection of concealed spaces that's given in NFPA 13, the sprinkler standard itself. So this does open up a new opportunity for concealed spaces if they're protected. That protection would be either lined with non-combustible material, filled with non-combustible insulation, or protected by sprinklers in the concealed space. So that's now permitted for, in the 2021, that will be permitted for traditional heavy timber construction.
Great, excellent. All right, one more for each of you, and then we'll wrap up here. Jason, question about seismic provisions and where we stand with CLT and seismic provisions.
Sure, yeah. The ASCE seismic design subcommittee is working on some provisions that would include seismic design coefficients within the 2022 version of ASCE 7. So that the target is to have it in ASCE 722. That's not a guarantee, but that's the aim. And if it makes that target, then it would be picked up in the 2024 IBC. So that's when you could expect to see such seismic design coefficients and related provisions for CLT design.
Okay. And Paul, last one on flame spread, smoke developed indexes, kind of some existing code provisions for that, but maybe just touch on that as it relates to new tall wood provisions.
Yeah, there's no real change to the required flame spread indexes in Chapter 8 for interior finishes. That would apply to exposed CLT. Flame spread of CLT is easily determined. We have DCA1 document that shows flame spread ratings for particular wood species. So that's not really going to change in terms of flame spread or smoke developed for interior finishes. There is one thing that did change in the last cycle in exit enclosures, since CLT might be used for exit enclosures, but it can't be exposed anyway, so I'm not really sure it serves a purpose, but you're not going to be able to have exposed CLT in exit enclosures. So there was a change to Chapter 8 indicating that in regard to finishes, final finishes for exit enclosures. But other than that, everything will be the same.
All right. Well, excellent. Thank you both for a great presentation. A lot of good information here. Folks, we'll let you go and hope to see you again next month for our webinar, and look for some email from the education team about your certificates. So thank you all, and have a great day.